Hello everyone. In this video, I will demonstrate how to plot ROC curve, lift chart or gain chart, cumulative lift chart, and decile wise lift chart using Excel. So this concepts are being used heavily in data mining. So I thought maybe it will be very helpful to put this in an Excel and see exactly how these graphs are being plotted. So here is the data. So we have actual class being predicted as 0 or 1, that's binary. And then we have the probability estimate. This is being generated by let's say SAS Enterprise Miner. So we have arranged this in the descending order of the values as you see from top to bottom. So and one being a responder, and that is of interest to us. So we want to identify as many responders as possible, and zero means non-responder. So the category of interest is responder. So with that, we have these 24 records, out of which there are 12 ones and 12 zeros. So 12 responders and 12 non-responders. So it's kind of a balanced sample. And here I just list off the cutoff values which we will use later on. So if the cutoff value is 90%, that means this many records gonna fall above that cutoff. If the cutoff is 80%, then this means this many records will fall. This many records will fall above that cutoff limit, and henceforth. So when you're dealing with the data like this, we always want to, find out the responders, how responders are being predicted versus non-responders. So we have this classification matrix here. So we have, let's say, predicted class here, which could be responder and non-responder. These are the actual class for the data. The actual class are given here. That's coming from, let's say, the validation data set. So if you correctly identify actual responder as a responder, then that's a true positive. If you correctly identify non-responder as non-responder, that's true negative. If you incorrectly identify non-responder as a responder, then that's a false positive. And likewise, if you incorrectly identify a responder as non-responder, that's false negative. So here are some definitions here. True positive means a proportion of responders correctly classified as responders. False positive is proportion of non-responders incorrectly identified as responders. So actual value is non-responder, but you predicted them to be a responder. So you can organize in this fashion as well. Let's see here the actual classes. So if the actual is a responder, but you predicted them to be non-responder, then yeah, I'm sorry here. If the actual class is non-responder and you predicted them to be a responder, then it's a false positive here. So it doesn't matter how you organize the classification matrix, you still end up getting the same formulas here. So sensitivity, these formulas you can find on the website anywhere from Wikipedia. That could be one of the best source. So sensitivity, which is also known as true positive rate, is basically the proportion of responders currently identified as responders. And true negative rate is also known as specificity, which means that the proportion of non-responders correctly identified are classified as non-responders. So false positive rate is often given as 1 minus true negative rate or 1 minus specificity, which is given by this formula here. So let's say the cutoff value is 0.5. So how are we going to populate this matrix here? So if the cutoff value is 0.5, we can see that these many records will fall under that criteria. And you can see that all these values above 0.5 will be predicted as responders. Okay, so in that case, you are truly identifying all of them but two as responders. So these are the 13 records. So you predicted 11 records correctly, and your false positive is two here because you are identifying two non-responders as responders. So that's false positive here. And likewise, you can all these records here will be categorized as non-responders. So you are correct identifying these are I would say these how many records are there? These are 11 records. So out of which only one is being incorrectly identified. So non-responder two negatives are 10 and one is false negative because you are identifying a responder as non-responder. So that's false negative. This is how you populate this uh, classification matrix here. Uh, with that thing now, let's move on and see how exactly we can go ahead and plot the ROC curve here. So here I have already populated the data set, but I'll walk you through for a couple of records here. Let's say if the cutoff value is 0, that means all the records are being predicted as responders. All the records are predicted being as responders. So basically you have 12 positives there. Okay. So true positives are 12. You are not identifying any record as non-responders. So true negatives, there isn't any true negative. So it's 0 here, if that makes sense to you. Because we are identifying all the records as responders. So there are no negatives, no non-responders. So true negatives are 0 here. Likewise, let's say the cutoff is again 0.5 here. Okay. So likewise, if you see that 0.5 here, I'm going to go here and I highlight all this table here. So here there are 12 records out of which I'm sorry, these are these many records from here. So there are 13 records out of which 11 are true positives. Okay. And rest of them are, so all these records are classified as responders, and all these records are classified as non-responders by our model, out of which true negatives are all but this one. So there are 11 records, so true negatives going to be 10. That's how we got this value here, and that's how you have to populate the rest of the records. Okay, so this is being done manually. So let's go ahead and do the total negative rate, which will be given by this value here. We're going to divide these by total negatives in the data set, which is this one. I'll fix that cell here, times 100. That will be my true negative rate here. False positive rate is basically given by 1 minus 2 negative rate. So I'm going to say equals 1 minus this rate here. True positive rate will be given by this value here. True positive divided by, I will say, total true positive in the samples are 12. So this is going to be 12 here times 100. You can also do that again here, like say 0.5. You can also calculate the false positive right from the sample here. For example, 0.5, if the cutoff is 0.5, as we have noted here, how many true positives are there? See, all the ones are true positive because all these records are being classified as responders by our model. So 11 are true positive, and false positive are 2 because we are incorrectly identifying these two non-responders as responders, and that will be our false positive. Okay, as you see here. Right? We are incorrectly identifying two non-responders as responders. So that's 2. So you can calculate from there, or you can just subtract 1 from the true negative rate, and you'll get the false positive rate as well. But you can do it from the data set just to make it more clear. And once you have that, we can just write this thing down. Okay, there's something I'm not doing right here. Uh, let's see here. This should be 100 minus. So that was the thing right wrong here. Then I can just drop it down. So we get all this false positivity. Now, ROC curve, we can just plot based on these two values here, because on the x-axis you will have false positive rate, and on the which is also equals 1 minus specificity, and on the y-axis you have total positive, true positive rate, which is also known as sensitivity. So this is 1 minus specificity, and this is sensitivity. So we're going to plot this one. Let's say insert. So this is our what we call ROC curve. And you can always format the axis and everything. Just make it 100 here, and you can also add axis labels. So you have false positive rate, which is equals to 1 minus specificity. And this is true positive rate, which is also equals. Okay. That's how ROC curve. It kind of shows you the trade-off between the true positive rates and the false positive rate. So obviously, if you draw the diagonal line from here to here, you want to be on the upper side of the curve, because that diagonal is basically the random guess. Because if you flip the coin, any record could be classified as true positive or false positive. So that's what the diagonal line will represent. So you always want to be this curve should be as steep as possible to get the nice prediction. So for example, here basically we are saying that you get better true positive rates for the top 20%, and then basically it kind of tapers off and you reach the same level as 100%. Okay, so with that done, let's move on to the lift chart. So in the lift chart, basically what we are doing is we are plotting the lift against the percentage of top records. So for example, here is what I did. I uh, jot down all the top records here. For example, 0 top record, 4 top records, 8 top records, 12, and hence 4. And you can convert that into percentage. For example, 4 records out of 24 equals 16.67%. So you can also see the formula here. So this A29 may be coming from here. That's 24 records we have. So you can convert that into percentage. And now what we're going to do is we're going to go and you can find this value, actual values. For example, true positive. So if you go to first 4 records, let's say first 4 records, all are being identified correctly as true positives, right? So I'm going to say true positives are 4. But if you don't use the model and you randomly select 4 records out of this 24, what is the probability of getting number of true positives. So that will be given by the proportion here. For example, you have 12 responders out of 24, that's 50%. So 50% of 4 is going to be 2 records, because if you randomly choose 4 out of this 24, the chances of the number of true positives or number of responders correctly identified are 50%. So that's going to be 2. That's how we get to here. So if you see the formula here, say, so we have number of records times that fractions coming from here, right? 12 divided by 24. Okay, and that will be kind of dependent on not the top or bottom records, but the total number of records. So here is 50% of 4 is 2, 50% of 8 is 4, 50% of 12 is 6, and henceforth. But this one you have to manually record from the data set. For example, for the 8 top records, you can go here and you can see that true positives are 7. Okay, so I'm going to record that here, true positives 7. For the 12 records, so for the first 12 records, you can see that you have only 2 false positives. So you have 2 negatives as 10, and that's what we found out here, right, for the 12 records. And you can populate the rest of the table like that. So I'm gonna make sure, if you want to replicate the same thing, maybe you can pause the video here, try to populate the table, and try to follow the steps as said in the video. Okay, so here it's called cumulative because we are adding records to the original records we already selected. For example, 0 to 4, and then we're not taking next 4, we are taking 0 to 8, 0 to 12, 0 to 16. So it's cumulative. That's why it's being called cumulative lift. So cumulative lift, basically when you don't have any records, I would say lift is 0. So we don't need any formulas there as such. But here cumulative lift is going to be number of true positives identified by the table divided by the our what we call random guess here using the base model. So that's going to be 2, and then we can just populate this one here. Okay, now we can plot the chart here. For example, let's plot the cumulative chart or the gain chart. So I'm going to select basically, let's do these 3 things here. Okay, so I will go to insert here. So yeah, that's our see, this is my lift chart. So lift chart, or also known as gain chart. Yeah. And I always like giving name to my axis here. So I'm gonna say here primary axis. So here we have, say, top percentage of records. Okay. And here we have, let's say, true positive. I'm going to say cumulative, true positive. Okay, so that's our lift chart. Sometimes you also plot cumulative lift chart. So depending on that thing, so what we can do is I can highlight this table here and this column here. I would say insert. So generally we don't plot the zeros. Okay, so basically what I would do is I would identify this. Okay, so let's do select this data here. So insert. Okay, So that's what I was looking for. This I guess this is not right here. Okay, let's do it again. So top end records, I would let's see, this one. What we can do is we can blank it out, so we don't have any data set there because there is no community lift there. Okay, so maybe I can do this one. I'm sorry, control, and then control this one, and say insert. Let's see what we get here now. Yeah, that's right. Right. That's a community lift chart. You can always, format the axis here if you want, and this axis also, I would say I just want to go up till 2 because that's my maximum lift, and I want to minimum is going to be 1. Okay. So that's the community. I'm gonna put my so here again we have top percentage of records, and here we have okay. This is how you do. This is another. I'm gonna just make it a little smaller. I'm pretty sure I'm gonna make this also. Okay. Now sometimes you also need to plot the decile chart. Now the decile chart simply means that you divide the records into the 10% of the total record span and plot the chart. Since we don't have the number that could be evenly divisible by 10%, so I'm gonna use just 4 records at the top. So we instead of having 10 categories, we'll have 6 categories here. But this is the concept you use in while you're plotting the decile chart. So basically, you have first 4 records, so that's decile number 1. Next, from 4 to 8 records, it's going to be decile number 2. From 8 to 12, it's going to be 3. Fourth, from 12 to 16 is going to be 4, and hence 4. And here you have to basically calculate the lift for each decile. So for the first record, we know the lift is, basically I know like the first 4 records, you have 4 true values identified by the model and the 2 by the base model. So it's going to be 4 divided by 2 is equal to 2 here. But what we can do is, so that we can write the formula down, we're gonna subtract this value from the earlier records and uh, do it that way so that we can copy the formula down. For example, here the lift is going to be this minus earlier 4 records divided by this minus my earlier 4 records here. So we don't have there, so it's going to be 2 there. But for the next is going to be populated accordingly. So for example, for the next 4 to 8 records, your cumulative true positives went from 4 to 7. So in a sense, you're having 3 true positives identified in the next 4, and your random guess or the base model will always random. For example, if you randomly select 4 records, your lift will always be 2 here, and you can see that here as well. For example, in the data for the first 4, all are true positives, so the true positives are 4. For the next 4, true positives are, I'm going to say, 3, right? But if you randomly select 4, you can expect to get 50% of the records as responders. So That's coming from again 12 divided by 24. That's the proportional responders you have, and that's what the base model will predict. So your model is supposed to do better than the base model. So in the next four here, you have again three true responders, while two as your base prediction, right? So here for 8 to 12 you have three, and 4 to 6 you have two here. So that's going to be giving you a lift of, I would say, 3 divided by 2, which is 1.5. And this, you can see the formula here again. Okay, that's how you do calculate the lift here, and you can plot this one. For example, I can highlight this one, and I'm going to say insert this chart here. Then I will, since this is the numeric values is plotting at here, we can always polish that one here. So I don't want to plot the lift. I'm going to remove that, and horizontal axis, I'm just going to select. Okay, let's edit that here. I don't want to select this one. Okay, that's my decile chart. Okay, so I'm gonna call this decile wise lift chart. Okay, so here I don't want this thing here, and I want to add my access style here. Okay. So here you have deciles, and here you have lift. This is how you see the decile chart, and this is how you interpret the decile chart. So basically, if you see all this one, so the ROC curve should be as steep as possible, should be away from the diagonal on the upper left corner. You don't want to be the diagonal or below that. That's not going to be a good model. The good model should always be predicting more true positives than false positive in a given proportion of the data, and that's very common in marketing. For example, you want to send out the marketing coupons to top 20% of the records because you have limited budget. So you want to send out the coupons to those people where you have higher probability of getting the response rate, and you can see that you're getting very good true positive response rate here compared to the base model. So here also you can see the community lift should be as steep as possible. This red line is the base model, which means it's kind of a random guess because we have 50% responders and 50% non-responders. So it's like flipping a coin. So if you don't use the model and randomly select the top 20% of the records, 50% of them you can randomly say will be responders. But if you use the model, you might end up getting a better response rate, better than the average. And this is also a cumulative lift. This basically used for comparing many different models. So you have decision tree, you could have a logistic regression model or other type of models, and they can all create cumulative lift chart, and you can see which model is giving you the better lift. The higher the lift, the better. Okay, the steeper the ROC curve on the top left side, the better it is. It should be away from the diagonal. And this is the decile chart. You see that the first decile is giving you the highest lift, and it goes down until you hit zero here. So this is a brief introduction. The focus here was how to use Excel to plot this kind of charts rather than explaining the concept of ROC and other stuff. For that, feel free to read books, or you can find ton of online resources. I hope this is going to be very helpful understanding the basic concept. And with that, I end my video here. Thank you very much for listening.